We're ready for our next session. So in this session, we'll hear from the Data Science and AI Academy at NC State and from the Computer Science Committee that was tasked to develop an undergraduate course on fundamentals of applied AI for engineering. First, it's my pleasure to introduce David Stokes. He directs the teaching and learning in the Data Science and AI Academy at NC State. He has worked in STEM education for over 13 years in instructional, administrative, research, consulting, curriculum, and professional development roles. He's two-time NC State alum, where he completed a master's degree in statistics and a PhD in mathematics and statistics education. David also has a second master's degree in statistics and master's degree in transition special education. Currently, David works on collaborative data science and AI curriculum and pathways to reach the entire NC State community. He teaches DSA 201, Introduction to R and Python for Data Science, where he co-authored a textbook as an open source guide for project-based applied data science and AI teaching and learning. Let's welcome our speaker.
Okay, thank you, Edgar. And good morning, everyone. Nice to see you all. I'm David Stokes in the Data Science and AI Academy, and I direct the teaching and learning in that space. And I'm just going to talk to you all briefly about data science and education, and data science and AI education in the Data Science and AI Academy. So, firstly, just a little bit about the Data Science and AI Academy. And in this picture in the middle is our executive director, Dr. Ray Levy, and two students who are early Data Science and AI Academy students. And the one on this side here was also a course collaboration leader, which is the student group that I work with, and they support DSA courses, which I will tell you more about. But just a bit about our background. The DSA was created in 2021. With the idea to transform NC State into a data science and AI university as a whole. So the way that we enact this vision in the DSA is by offering project-based one-credit course offerings. And these courses are currently taken by faculty, staff, students, and other partners across North Carolina, other learners. And our courses are also used in curriculum across the university and can be used in additional curriculum. And I'll tell you more about the pathways that we are working on here as well. So our goals for these pathways are to basically create them for the entire NC State community. So this is an interdisciplinary effort, and it involves all colleges across the university to work towards this goal. And in general, what we want to be able to do with our existing curriculum, which is already, there are already many pathways such as those in the engineering space, is to be able to complement those curriculum, supplement those curriculum, and just establish collaborative opportunities for more students so that they can pursue data science and AI across NC State. And also this extends to faculty and staff as well. So my focus is in the 4-credit curriculum space in working with students, but we also have a training space, a customized training space called Data and AI at Work. So in terms of DSA teaching and learning, again, my role is working with students, faculty, and staff, and basically the DSA teaching and learning community, which includes curriculum development and more. And for our instruction, we work with both internal faculty and staff, as well as partners from industry and other academic institutions. And so the way that we sort of keep this group together, we'll talk about in the next slide, but we also offer courses in both synchronous and in-person formats, so that opens up a lot of opportunities for us to be able to reach or work with folks across the nation, really, and in particular here in North Carolina. So a little bit about the design and implementation of our curriculum. Again, our courses are designed for everyone, and we provide an entryway into data science and AI through our course structure, which I'll also tell you more about. But this basically involves collaborating with all colleges again and all we have a goal to reach all departments. We started on communicating with the various departments across NC State and have reached a third of them at this point, and hope to complete that goal very soon. So secondly, our course development all follows the ADAPT model. This is our course-specific model, and it stands for the All-Campus Data Science and AI Project-Based Teaching and Learning Model. And in this model, there are three components. So the first one is project-based learning, and that is basically intertwined with the third one, which is workforce development. So in all of our courses, the thing that you would notice right away if you were to go and observe, or if you were a student, is that you will complete a project, at least one project in that course. Oftentimes, it is one project that's integrated throughout the course over the semester, but sometimes there are several mini projects within a course as well. So the second component is 10 common learning elements. And these are broken up into three categories: data perspectives, data practices, and data discoveries. So throughout these 10, we don't expect all instructors to fit these in within the 1 credit course on top of their topics that they're already teaching. So the idea is that they're aware of them, and as students pursue something like a data science and AI credential, they will have seen all 10 over the course of that process at least once. So the third thing, again, is the workforce preparedness. Because our courses are applied and project-based, it gives students a platform to really speak about experiences that they had working with real data in the data science and AI space. So returning to our instructor community, we bring the industry folks together with our internal faculty and staff and other partners through our bi-weekly instructor discussions, although they're offered weekly. So we build our community through that space. All of our instructors have an instructor orientation that they attend at the beginning, as well as an instructor guide to help them facilitate their course throughout the semester. We also have a chat group space where we stay connected, and instructors can post questions there and get answers from their peers. So it's a really nice community that we've had, and happy to say that for our external instructors, we retain them and they come back to continue to contribute to the Data Science and AI Academy. And it's very valuable because the academic perspective is built in, but then we also have the industry perspective, and those folks can also potentially bring in topics that they're currently working on that are new and innovative in that space. And so our offerings, again, they're all 1 credit, and we offer courses at 3 different levels, primarily in the undergraduate space. But the 200 to 295 level is prerequisite free. So students can take these courses without having any prior knowledge, although they often come in with some sort of background. These courses include like an introduction to R and Python for data science or AI ethics course. We have a data visualization course, and several other courses, an introduction to data science for cybersecurity at this 200 level. And then at the 295 special topic level, we offer no prerequisite special topics. And then at the 400 through 495 and 595 levels, the difference is that there are skill-based prerequisites. So again, students don't have to take a full course to pursue any of our classes, but accompanied with the description of these 400 and above level courses is a list of skill-based prerequisites that students will self-assess prior to enrolling, and then they are free to enroll in these courses. Those include offerings like exploring machine learning and exploratory data analysis for big data and other topics. We just implemented a permanent course on Apache Spark using big data sets, so students get to work with terabytes of data in that setting as well. And so there are more special topics that we can return to here, but I will go on to the next thing to tell you a little bit more about our credentials. So currently we have 5 disciplinary focused credentials working with collaborators across the university. These include a data science in business minor at the undergraduate level. We have a data science in engineering, analytics, and decision-making minor. We also have a collaboration with the Department of Design and then the mathematics department as 2 others. And then our newest one is one in the education space. So it's a data science in K through 12 education. And one of the ones that we continue to add to and is very flexible and is designed to create those pathways where they don't currently exist is the interdisciplinary applied data science minor. So this is sort of a living, updatable minor that includes courses from all colleges across NC State. And at the moment, although it is also in the university catalog because it's updated so much, it just lives in a Google Doc, and we can make those updates a little quicker prior as we agree with the collaborative units and send them to our university curriculum committee following that process. So students are updated and in the loop. And so one of the things that is great about our role is that we get to communicate all of the great things that are already happening here at NC State. So earlier this year, we launched a website called AI at NC State. And in the teaching and learning space at this website, we have basically sought to gather the current data science and AI pathways that exist, and so that we can communicate those to anyone who wants to see them. So this is public facing. Currently, it's very useful for working with departments so that they can go to the site and see what's there, what's missing, and add to it, provide feedback and comments. And eventually, we will turn this into a more student-facing thing where they can go there and find their pathway that works for them in their field. So again, the idea here is that because we're a data science and AI university as a whole, there is no particular data science major or department. It's a university-wide thing. So students can go to the College of Design and find an AI pathway. Students can go to the College of Agriculture and Life Sciences and find a data science and AI pathway, et cetera. And then on top of that, we already have our amazing statistics departments, the engineering program, the mathematics, all of those traditional pathways that currently exist. So our approach is university-wide and integrating things in that manner through an interdisciplinary approach. So given that we have more time, I'll go ahead and show you all this AI at NC State site. So within this, there's a mechanism to provide feedback, and okay, there we go, scrolling. So at the top, if you go study here, the curriculum and career pathways exist at this link. And we have information under each of the colleges. For example, in the College of Engineering, we have the computer science program, which is a clear data science and AI pathway, and they have the computer science artificial intelligence concentration, which also includes DSA courses, the engineering and applied data sciences, and civil constructional and environmental engineering, and we look to add to this continually. So as another resource, just to give you an idea of some of our special topics that we have coming up for our current semester, and these change semesterly, and those that are useful and broad enough, we make them permanent courses over time. So the ones that are currently being offered include a virtual reality exercise and personal health analytics course, and this is a collaboration with the Health and Exercise Sciences Department and an instructor there. An instructor from the College of Natural Resources will be offering the Citizen Science Data Analytics course. We have an introduction to network analysis working with CHAS faculty. And here's an AI for data science and no-code introduction. So as you can see at the 200 level, we offer these 4 special topics and then 3 more at the 495 level, including advanced supervised machine learning using a visual interface, and they use SAS BIA in that course. Other courses primarily use R and Python. But there are options for students to take these courses and substitute them in for their respective minors if they're pursuing something like that. And our permanent courses are listed below. So at any point, you can return to this website. Our descriptions are included, and at the 200 level, there are no prerequisites. And then the difference being at the 495 or 400 and above level is that all of our courses at this level are accompanied by a set of skill-based prerequisites that students will self-assess. So that's pretty much the structure that we have, and our offerings for this current upcoming semester and we continue to seek innovative special topics that we can integrate semesterly and allow students to pursue those to broaden their data science and AI experiences. So thank you for your time, and I look forward to questions following. All right.
Yes, thank you very much. We'll take the questions at the very end. We have another set of speakers as well, too. So while they set up over here, let me do a brief introduction. Thank you. Okay, next it's my pleasure to introduce Colin Lynch and Sarah Heckman. Lynch is an associate professor of computer science at NC State. He's a director of the AI concentration in the Department of Computer Science, lead instructor of the AI Academy, and co-developer of the Applied AI for Engineering course. Lynch's research is focused on the AI education and AI for education, including work in intelligent agents and student models for math education, coding, and writing. His recent work includes efforts to apply large language models to support classroom orchestration at the K-12 level. Sarah Heckman is an alumni distinguished undergraduate professor in the Department of Computer Science at NC State as well. She serves as the director of undergraduate programs and was the first teacher track faculty member hired in the department. Heckman is a 3-time graduate at NC State, earning her bachelor's, master's, and PhD degrees in computer science. Go ahead.
All right, good morning. So, as Edgar introduced, we're talking about AI for engineering. So, I'll just start with, why are we all here, right? Just general question. If you think about it, we're all here because we're in a situation where AI has just shown up at our door, right? Granted, some of us have been working on making that happen. But more or less, AI is in every field. And we're already, quick show of hands, we're all using AI in our research or basically plan to. Yeah, right? We want, of course, students to be prepared for AI-heavy careers, right? They are already knowing that AI will be a tool they have to deal with. And we know students are already using AI in our classes. Let's be honest, often improperly and usually without our assent, but they're using it, right? So we're in a situation where AI is already pervasive in our classes, but maybe not trained properly in our classes. So what we really need to think about is this. How do we prepare students for AI pervasive engineering, right? To be an engineer in the future is to be an engineer in a world where AI is all the way through your professional life, where AI is used to solve problems, AI is pushed upon you, AI is given to you, or AI is simply done without your consent or understanding, right? So just as we experience students using AI to, shall we say, clean up their work, to finish something out, flesh out some ideas, they're going to deal with people who do that same thing in an engineering space, right? They're going to have to learn to deal with that, being given the products of it. So what we need to do is think about a new set of skills, right? Engineers that work in an AI pervasive environment have to be able to apply AI as a regular tool, right? They have to be able to evaluate the products of AI models, be given something that was produced by AI, and judge whether it is good, acceptable, professionally relevant, and so on. They have to be able to integrate AI products into larger designs, treating AI as a black box, as a model component, as a tuning device, and so on. And exercise professional judgment around these uses. Are these appropriate uses for AI? Are they inappropriate uses? How do we bound it? And crucially, how do we communicate about it, right? To be an engineer is to work in interdisciplinary teams, so how do we train engineers, our current and future students, to be able to understand and assess AI, communicate about AI, and in this case, to AI experts, right? They're not going to become all AI experts, but they're going to have to work with people who are. They're going to have to communicate with their peers in engineering about the work they've done with or around AI, and ultimately to clients, right? If you are designing a system and you are relying on AI either as a component of that system or to help in the design, As a professional engineer, you have to be able to communicate about that to the end client. You have to be able to say, yes, I used it and here's how, or here's why you should trust it, or for that matter, as our keynote speaker mentioned, who's responsible? And usually the answer is nobody, or at least not me. That's most of the time the answer that's being given. As a side note, actually, an exercise I do in one of my classes is I have students read Tesla's end user license agreement. And if you ever want to feel uncomfortable about even being on the road with one of those vehicles, read the end user license agreement. It's a great example of polite non-responsibility for every single component of the car, and up to and including whether it actually stays on the road or even connected to the ground. So, that's the situation that these students are coming up in. That's the situation we're in. So ultimately, it comes down to this. How do we get engineers to incorporate AI knowledge into their professional identity as engineers? Not to become AI experts, but to say, I am a chemical engineer. How is AI part of that image? How is AI part of my role as an aerospace engineer, and so on and so forth? So let's just acknowledge that we start with a lot of classes, right? We've already got all the intro to AI courses in CS and ECE. We've got advanced AI, data mining, special topics everywhere. We've got the 1-credit DSA courses. We have loads of courses at the university. The catch is that most of those courses are either advanced undergrad or graduate courses, or they are special, the 1-credit courses that are focused on specific skills. What we're not getting, really, is stuff for the new students. What do we do for the brand new freshmen? Because they're coming in as students into a world where AI is already there, where they've probably already considered themselves AI experts because they've had access to ChatGPT, right? And when I say they consider themselves AI experts, as a side note, I do a lot of research on AI in education in the middle school level. And between last year and this year, in asking teachers what's the one thing they need to deal with most, the answer shifted from AI to support my classroom operation, AI whatever, to AI detector. Can you detect when kids used AI? Because they've hit a point where 12 and 13-year-olds already consider themselves AI experts and are already heavily reliant on it. So that's the group of students we've got coming in, people who used AI or at least had access to AI all the way through their K-12 education. And what we need to think about is how to get it integrated effectively into their undergraduate curriculum and ultimately graduate as well. So this gets us to the idea that was really brought to us as AI-first engineering. Not AI engineering as a core thing, but starting with AI at the beginning for our undergrads so that they recognize appropriate and inappropriate uses at the outset. And also, to be honest, recognize that AI is more than LLMs, which, most of them don't get that either. So what we've been working on then is applied AI. And specifically right now, we are offering a 2-course sequence in applied AI for engineering. So fundamentals of applied AI for engineering, teaching that right now along with Dr. David Roberts. And in the spring, we'll have problem solving with applied AI for engineering. Sorry, it's slightly gangly title, but that's what we came up with. They're both currently listed as E298 courses. They're open to students across engineering. They are listed as tech electives for MAE, CSC, ECE, and nuclear engineering. Thank you for those of you who did that. Other departments, you can also add them if you wish. Please do so. Sarah will talk about that. But the basic upshot is we're offering these courses now. They are 3-credit courses. They are 298, which is the code for special topics. And the idea is to get students at the beginning to start working with the concepts of AI, really introducing the core concepts. So enabling technologies, foundational technologies, domain and problem models, specific uses of AI for different engineering areas, specific domains applications, so, chemical analysis through AI and so on and so forth, but also ethical, professional, and policy concerns, right? At the outset, when is it right to use AI? What are the concerns about AI? Can you trust AI? And I can say as an aside, one very disturbing thing is how much they trust AI coming in. So in fact, in hindsight, I should spend more time teaching the class, telling them not to trust it, because they come in with a remarkable amount of faith in AI to get things right, spell things right, type things right, make code work, all of it. And we also, and I will say, introduce also a lot of shared tools, AI libraries and notebooks. We have a Jupyter Hub server running. Thank you very much for that. And so we're getting students to use AI, not assuming they all have a GPU on their laptop, but that we can actually access cloud systems that have been set up by the College of Engineering, which gives students the ability to access the AI libraries and also gives us a uniform platform for work, right? It gives us something we crucially need, which is for students who are not coders, but who want to run and analyze and evaluate data, a uniform platform on which to do instruction, and one that I hope will be available to other classes. It's an open question, John. But at the end of this course, our goal, I won't read through all these, but basically we want students to be able to understand, identify the core concepts. We want them to know what AI is beyond their initial narrow assumptions that AI is ChatGPT, right? And we want them to align those tools with problems in engineering, crucially in engineering disciplines they intend to major in. So again, the goal is not to make everybody major in AI, it's for them to come into MAE, nuclear, whatever, prepared to use AI appropriately and prepared to contribute to advanced research around AI. So the fall course, just to give you an idea of the topics we're covering: ethics in AI, data representation, some data science, heuristics in search, optimization, so on and so forth. For the spring course, get into some more advanced topics: explainable AI, AI testing, and so on. Crucially, I want to emphasize, these are not coding courses. We are pursuing a model of example-based instruction here, where we are teaching students concepts. We are teaching, or at least introducing them to the fundamental algorithms, and we are giving them code, which they expand or flesh out. But we're not teaching coding from the start. This is not a Python pair of classes. And that's one thing we are in fact evaluating, is whether or not this structure works. So it's an experiment. But the idea is that most of the departments already have a coding requirement. We don't want to supplant that. We want to work with that. All right? Format of the courses, just very briefly: weekly lectures, we're focusing on AI concepts; weekly labs, where they actually analyze data sets, implement models, or expand models and evaluate them. And the assignments, we have readings, so discipline-specific readings, where we give them, say, a study of AI using in a nuclear reactor, read the paper, evaluate it, talk about it. Evaluation of proposed applications: here's something that's done, what do you think about it, discuss it as a class. Execution, analysis of AI code: here is a notebook. Flesh out the notebook to achieve this analysis, then say what you think it's doing, compare your notes. Again, it's very conceptual, high level, but thinking about it, targeted engineering tasks. And then ultimately developing AI proposals. So the final project in the course is not to implement a full AI system, but to develop a proposal in your discipline area that you are interested in majoring. Again, this is for students who are intended to major in different departments. And put together a project proposal that would use AI as a component. Crucially, we're not telling them to do only an AI proposal, but one that would build on AI, work with AI, learn from AI, and so on and so forth. Because we want them to think about it as a piece of their engineering practice, not an end in itself. All right, so I've said some of this, but to give an example of some of the readings, right, we're having students read about classifiers for chemical reactions, AI for wastewater treatment, which got some surprisingly interesting reactions. They were actually oddly excited about learning about wastewater. And then execution analysis, doing things like labs where they do multi-objective optimization of airfoil design, fairly straightforward optimization problems, or we have forthcoming labs where they're extracting data from, in this case, crop reports and soil reports using large language models and fine-tuned models. And then we'll turn to future plans, but I'll hand it over to Sarah. Oh,
okay. I'll just use this. All right, so we are creating all these fantastic courses that we're really excited about, but one of the challenges with creating new courses is how does it fit in existing curricula? How can we integrate this so as many students as possible can take these courses and have it count towards degree? So our plan is to take these special topics courses that we've been offering this academic year and make them into official numbered courses under the E prefix. So it exists under the engineering prefix. We're probably going to go with 211 and 311 because that aligns with our AI 411 course in computer science. It aligns with an engineering AI course. And so we'll probably take those numbers, but we're welcome to have feedback on those. The idea is that the first course, this one we're offering this fall about fundamentals of applied AI, is going to be offered at the 200 level. It will likely have a co-requisite or prerequisite of a programming class, which could be our Python course, CSE 111, as well as the other discipline-specific programming courses that are offered across the College of Engineering, and potentially those even more broadly across the university. So the idea is that they are going to be taking basic programming concepts as they're doing the applied AI work, so they understand what's coming in on the notebooks and the other different types of project elements that they're working on. The idea is that we'd like to make this E211 into a general education program interdisciplinary perspectives course. All of our students across NC State are required to take 5 credit hours of GEP, or general education requirements, under interdisciplinary perspectives. 2 of those hours are E102, and we'd love for the other 3 hours for our College of Engineering students to be our E211. So it's a very nice way to insert this into degree programs really quickly. Our E311 will be offered as a secondary course up. It'll be at the 300 level. This will help it slot into tech electives, into various engineering programs, so that students can take that and have it count towards degree with these just 2 courses individually. More broadly, we'd really like to expand these courses to accommodate engineering-intended students. So right now we're offering small sections of about 50 students this semester in the E298. We're going to hopefully be over 100 in spring for our problem-solving one. But we do eventually want to scale up these courses so we could potentially teach every single engineering student should interest go in that direction. And we'd love for these courses to form the foundation of a minor in applied AI with an engineering focus. So students would be expected to take one coding course, so like CSE 111 or 116 or some of the other courses across the College of Engineering. They would take E211 and 311. Those are 3 of the minimum 5 courses required for a new minor. So we'd love to then see some type of course that uses AI that's relevant to their major as part of this minor, and then a project-based course in AI. And that might be within the major, it might be undergraduate research where they use AI. So there's lots of different ways that we could define what a project-based course looks like. And this is a place where we love feedback from the rest of the college about how this might look in your programs, what you might want to see from an applied AI minor, and how students might participate in that inside your programs. So we actually have some questions for you all, and I know that we have some time for questions at the end of the session, so I'll get to those in a moment. But I also want to invite you to maybe join Colin and I for lunch. We'll probably find some tables over there, and so if you want to have discussions about what this might look like, what's important for you and your programs to know about how applied AI might matter in your courses, especially as you start welcoming AI into classes in discipline, we'd love to have some conversations about that. We also would love to have some people eat lunch with us, so we'll be over kind of in that direction for lunch if you want to join us for discussion. But the questions that we have for you all is, are there topics or applications that we might have missed in our fundamentals and problem-solving AI, applied AI courses that we're developing? Are there problem sets or data sets that you feel like would be of interest to engineering students in your discipline that we could then integrate into these courses and give the students an opportunity to explore how applied AI can support solving engineering problems? And then what specific courses, assignments, or research tasks do you want your students to be prepared to use applied AI for to help support those activities, to augment them as researchers as they participate in undergraduate and then hopefully further along graduate level research? All right, so with that, I think we're going to be open for questions from the audience.
Let's thank our speakers. Yes, we're going to open it up to questions. So there's a person right over here. There's a microphone coming to you right from behind. We'll have somebody else there.
Hi, thank you. I can't help you, sorry, with topics to let's see, the academic level, because I come from the industry. And one thing that I didn't see, I may be wrong, which is extremely important to the industry, is forecasting in the sense of risk. For example, You gave examples of optimization processes and so forth. All of that are very important. But one thing that we miss in the industry, and it's to us is very complex. People are not prepared to solve problems like that. I myself had to retrain to try to learn some of these techniques. Is forecasting, let's say, condition risk based on, for example, Markovian processes, which is not complicated. Statistically, something may sound complex, but it is not. Like state transition and things like that, that you can forecast risk in the future. So if kids can come out of school already with some notion of this, they will come to the industry, as you know, most of them. They will not stay in the academia, right? They will come to the industry, and this is extremely important to the industry.
I may have skipped over, we do plan to do some Markov processing in the spring course and sequential modeling, which would touch on that. I don't know, I haven't made all the slides yet, but I don't know if we particularly touched on risk, but yes, that's a good point, thank you.
Okay, thank you.
We have another question on that side, just a second. Meanwhile, is there a third question? Let's identify people. We'll come back to you while you think about your question. That's the next question.
Thank you, Colin and Sarah, for the great effort on the 200 level courses on applied AI. I'm also a colleague who teaches AI and machine learning in another department. So I looked at the course content of the first AI course, 200 level course. So my feeling is that the course has a heavy concentration on research algorithm, which we usually believe that was like the focus of the first AI wave, and now we are in the third wave, which basically the statistical thinking and the large language model are prevailing. So I don't want to ask for too much content in the course, but I would just want to ask about the rationale of having like the search algorithm as the main backbone of the course versus like having more large language model or these modern things as the from the consumer application perspective. So why would we would not have that, right?
I wouldn't characterize it as the backbone of the course, and we do cover large language models. We will be covering them this semester, in fact. We're getting into neural networks as well and other things. The main reason we start with search is a way of getting students to conceptualize what models are doing and what AI is generally, right? Thinking of it as search over different model spaces. And so I use that as a through line of the course to get them to understand what it's doing. When we get to Markovian processes, large language models, right? It's a functional transformation over the space, and it's a search over possible models to do the training. But we definitely cover the others as well. And one of the other reasons I start with search in the materials is students come in thinking large language models are AI. And I feel like you have to start from the bottom and get them to understand more of what's going on. Otherwise, they keep asking for prompt engineering and think that they've stopped there. And that's just not AI. That's a hill I will fight on from to the finish. So we do cover that, and I do want them to understand the breadth of modern AI. I just want them to understand it. I guess I come at it from wanting them to understand what's going on under the hood. And I think search as a model for AI is a good way to do that.
Yeah, thank you, Colin. So just to add a little bit, maybe bias the request.
Sure.
The second wave is actually statistical thinking. The first wave is computational thinking. So if we can add both, right, the statistical thinking also in the course, then that would make the student, more better equipped.
I may not have shown it on the slides. We do discuss statistical thinking in both semesters, and we have that planned. Starting with, basic understanding of distribution, probability-based AI, moving into decisions and Markovian processes as well. So that's also a through line of the class.
Thank you.
Sure.
There's a question right behind.
Hey, I'm Avi, and just to clarify, I'm from the industry, so that's what you use. I love this idea. This looks like a great course for the freshmen coming in. I have several students at NC State who are doing CSC, CE, and aerospace right now. I think they would greatly benefit from this. And as somebody who's worked with NC State students as interns and full-time employees, this is an awesome course for them to have. One point I would like to add is you mentioned that you're not emphasizing on coding. I think it might help to have them do a little bit of it. The vibe coding, for example. And I'll give you a real world example. Working in the healthcare industry, working in a large health system in North Carolina, the CIO was giving this example. They set up this whole coding platform, and one of the immunologists who had never had any programming experience was able to go into the platform and build a whole knowledge-based system for themselves. And that the IT department would have never been able to support them to do that. So as you're thinking about nuclear engineers or mechanical engineers, even doing Excel spreadsheet and programming with that, I think that would be a fantastic opportunity, and we should not skip on the vibe coding, even though as VSPs.
Yeah, I should clarify, we are giving, so when we give students, for example, notebooks, we're giving them, preloading a Jupyter notebook with some code but not complete code, and having them think through how that's expanded out and think through how it's built. The key thing is there's already coding classes across the department, so I didn't want to teach them Python again. In the classes, we want to co-rep.
What I'm talking about is build an entire application end-to-end. Database, back-end, and the front-end. Because unless you see the front-end, that you are part of it, it doesn't have that real impact. Even if they're doing something really simple, calculating something, that is powerful, and it doesn't take very long with the tools that are available right now.
And that's, as we get into, one of our interests with the project-based courses that we want to build these into would be to get students to go through that cycle, preferably as part of an interdisciplinary team. So they really get the experience of thinking about the full application, but also communicating with people who are from different departments and so on. There's one frustration I have now is that every time I get them to team up, they find somebody who's from their department that they already know. Same.
And maybe, David, I guess, through the DSA, I think there's some courses that are offering basically some of that experience as well, too, right? Like front end all the way to back end, full stack, I guess, in some sense, right? Do you want to comment something about that?
Thanks, yeah. So in many of our courses, we emphasize the data science workflow. So that looks different depending on the particular course. In the one I'm most familiar with that I teach in Intro to R Python for data science, we start from collecting the data, building the data dictionary, posing a question, digging into it, and then they communicate the results as the end goal through a presentation. So definitely in our workforce development and our applied focus, that is a consideration that we emphasize, and it looks different depending on the topic, but they do go through sort of like a project, real world scenario to produce their class outcome.
Great, thank you. I think we have one more question over here. Mike, is that coming?
Hi, good morning again. My name is Samudra. I'm also representing industry's point of view. So one thing I think would be important to have an underlying assumption that we make about anything to do with AI is that there's cloud connectivity and online access all the time available. In industry, there are, especially in the critical infrastructure side, there are several use cases. In fact, most of the use cases, for example, nuclear industry or power generation, electricity transmission, metro rails, where online connectivity is absolutely no-no. So how to translate and train these models using AI and machine learning, and then be able to transport or transpose them and use them in offline situation. Having that practical aspect, because the challenge is not just building an AI model and deploying it. How do you again train it? How do you make it better in offline situation? And then continue to improve upon it. Having that process documented, the future engineers trained on that would be extremely helpful.
I agree, and I think what you cited there is, and what we've tried to do in the course is, seeing this as being for freshmen primarily is where we're really aiming. We assume they're coming in, they intend to be interested in, say, nuclear, right? But they don't know enough about it yet. But with the minor, our goal would be to get to the point where in their later classes, they are absolutely taking a course in the nuclear engineering department that is specifically about those kinds of issues. Like, what are the requirements that are different, or what is the project that's specific to this, and dealing with exactly those issues that in nuclear, they have just different reliability requirements than, say, civil, right? Or different goals entirely in how they would use it. Because like I've mentioned the challenges of cloud connectivity. I've used, self-driving cars as an example when we talk about ethics, right? Here's a vehicle that has to be certified as a whole, cannot be changed while you're driving, versus something else, which might be, say, a chatbot for finding chemical information, which could be continuously updated. But the specific, discipline-specific requirements like that, I think, are something better suited to a later class where they know a bit more about their domain. And now it's, what are these specific issues of AI in aerospace? What's different about aerospace versus something else? And that's why in our plan for the minor, we really want to think about finding courses, many of which already exist in our departments, which are specific to the department. So we can say to a student, you can get the minor, but now you need to take a class that is your discipline issues, your discipline methods, so that they're ready for exactly this.
And just kind of following up on that, as he was mentioning, different departments are doing different things depending on the type of requirements. For example, in ECE, we have wearables with AI capabilities where we're looking at deployments on embedded devices, essentially, like all the way there. And then other departments may be looking at other things like deployment on robotic type of systems, right, where there's be some constraints as well. So yeah. But one last final question.
So I'm looking at AI through a pedagogical lens, and I'm concerned about undergraduates in particular, maybe graduate students as well, understanding how they should be using AI in their professional lives and ethics that are associated with that from a professional licensing perspective. And what I'm finding is the students don't understand that. They're happy to go paste a question into ChatGPT, write down the answer. They have no idea whether it's right or it's wrong. It's just between them and beer. And I'm concerned that we should be educating them in terms of what things they really need to know and what things they can go look up and how they should be using AI. And that's independent of writing code or generating things from a technological standpoint with the support of AI. I think they need to understand philosophically how to use it.
I agree, and that's why week 2 is literally ethics and the limits of what you should do with AI. Because I exactly see this, and in both the undergrad and grad levels, students come in and they're content to paste an assignment into ChatGPT and they don't get why that's wrong, or worse, since I do a lot of research on AI in education, having to explain to students that no, you cannot find a random website that will clean up a JSON file and then paste in protected student data. Like, they haven't wrapped their heads around the idea that that is in fact sharing with a third party. So I would argue that we probably need to do a lot more than we can do in this class. I would agree with you that it's a problem, but definitely in this class we front load that exact issue. We start from the beginning telling them, here is the problem. And here's also what you're missing out, because I find that in dealing with students that we're getting, a lot of them didn't develop foundational knowledge precisely because they had easy access to AI. And so and CS students in particular, you didn't learn how to do the basic coding in like the 116, so you hit like a 216 or a 316 and you fall off a cliff in terms of your abilities. And that alone is an issue you have to confront. So.
Okay, let's thank our speakers one more time. So it's time for